Okay. Hi, this is John White with Frederick and Company, sponsors of the World of Private Offerings. You know it takes 2,900 gallons of water to make one pair of blue jeans? Today, there is a worldwide water crisis. Not because of blue jeans, but water is a limited resource. Today our guest is John Grisdeel, CEO of 9Power Clean Water of Golden, Colorado. His company has developed a breakthrough technology that adds to the water supply by reusing contaminated water. Without further ado, I'd like to introduce John Grisdeel. Gris?
Well, thanks. Appreciate it, John. And thanks for spending some time with me today, and all the people that have logged on to learn more about 9Power Clean Water. I want to talk to you today about water and what our company is doing to help the planet make the most of our dwindling resource. As you know, water is the most important thing next to the air we breathe, and it's becoming even more and more difficult to come by. Scientists and researchers have been saying for years that the next big war will be fought over water. Well, no one can really predict if that'll happen. It is known that the total usable freshwater supply for ecosystems and humans is less than 1% of all the freshwater resources. And water use has been growing at more than twice the rate of the population increase in the last century. According to the United Nations, today almost 2 billion people, or 1/5 of the world's population, live in areas where water is scarce. Specifically, water withdrawals are predicted to increase by 50% over the next 20 years in developing countries and 18% in developed countries like the United States. So by 2025, 800 million people will be living in countries or regions with absolute water scarcity. And 2/3 of the world population could be under stress conditions, leading to the displacement of many, many people. Turns out there's only a limited amount of water on the earth, so how do we get more? Well, the most obvious thing is to recycle what we use. All kinds of water can be recycled or treated for reuse. This includes sewage or gray water from populations, seawater, and even industrial contaminated water. While most traditional engineering and construction companies build physically large plants using old technology, our motivation at 9Water has been to design and deploy modular machines that combine innovative technology in a manner that fits into people's existing workflows. The United States government figured this was going to be a problem too, and so they turned to Los Alamos National Laboratory for a solution just over 10 years ago. The LANL team's objectives were to invent the most effective water treatment solution for difficult-to-treat industrial contaminants, and then be able to deploy that solution for the lowest possible price. In 2013, 9Power Clean Water was founded, and we were granted an exclusive license to take the Los Alamos technology, turn it into products, and make it available worldwide. 9Power Clean Water put together a team that had the know-how and previous experience to bring together successful laboratory research and development, and we'd done so in the past. Now in 2018, technology has now become commercially available as a mobile, highly efficient, cost-effective, unique solution called the 9Water Treatment Plant. This solution took about 10 years and the assistance from the University of Texas at Austin and New Mexico Institute of Mining and Technology to develop, and it required 9Power Clean Water another 4 years to turn it into products that could be built and deployed all over the world. Today, 9Power Clean Water can treat water from the very worst contaminants and make it safely reusable. And we can provide this safely reusable water for pennies on the barrel, much less than what the oil and gas industry is currently paying, which ranges between $2.50 to $10 a barrel just to truck it off site and inject it into the ground. Other vertical markets include the textile industry, chemical factories, coking facilities, and oil and gas refining. I want to talk a little bit about the technology itself. It's fairly simple. It doesn't rely on chemical additives or lots of electricity, unlike other kinds of water treatment technologies. As you can see from the diagram, it's a simple series of tanks that utilize adsorbent, not absorbent, but adsorbent media that were specifically designed at Los Alamos to solve particular problems. For instance, we take out metals and metalloids in one container, and then all the other contaminants are allowed to pass through. This means that you've got a media that's specifically designed to just attract those contaminants it's after. And also it means that this modular approach allows people to implement our products in the way that fits with their workflow, which, as you can imagine, is very important in order to capture different market segments. People would like to leverage their existing investment in machinery. This next picture is a standard skid that'll process anywhere between 3 and 5,000 42-gallon barrels a day. It's interesting, the oil and gas produced water is actually measured in oil barrels, which are 42 gallons per barrel. And all around the world, we use different sort of volume and weight units for oil, natural gas, and water, but we kind of break everything down into either barrels or metric tons. In addition to the physical construction of our water treatment machines, we use specific media that was developed at Los Alamos just for each kind of contaminant that we're trying to remove. So again, that's metals or organic hydrocarbons, scalants, hydrogen sulfide, and even in the future, radioactive materials. The chart that you see here runs the great gamut of everything that we can remove. Oil and grease and suspended solids, those are the things that are floating in the water. They're actually pretty easy to get to. Biological organisms, well, our medias are natural biocides, so we can remove biologic bugs and organisms without the addition of chemicals along the way. We can also not only capture but destroy what are called dissolved phase organic hydrocarbons, and this includes things like benzene, toluene, petroleum distillates, things like that are found in a lot of industrial waters, especially in the oil and gas industry. Then more obvious things like lead and cadmium and chrome, iron, phenols, and various things that cause the absorption of oxygen and actually can cause problems if you take and put that water without proper treatment into a biologic area like a lake or a stream. And our machines eliminate all of those, and we do so for just pennies a barrel. Here's the chart that we actually prepared for one of our Chinese customer prospects. You'll note that our system removes, and almost hard to believe, 99% of all these elements. This is a completely revolutionary advancement in treating water for safe reuse. In most situations, we can assemble a system for our clients by adding or subtracting modules and components based on the amount of water that needs to be cleaned. Each system, again, handles between 2 and 3,000 42-gallon barrels a day, but we can gang those to treat up to 50,000 barrels a day. Total cost for treating machines, and our machines range in price from a couple $100,000 all the way up to $500,000 per module, and then you click together those modules to create very large plants. Works out to about 17 to 25 cents a barrel to treat produced water from the oil and gas industry, depending on what's on the water and what they want to do with that water, whether they want to reuse it in the oil and gas process, maybe for fracking, or if they want to use it to increase well pressure, and on the upper end, if they want to be able to discharge it to the natural environment. Now, this is a pretty big savings if you consider the fact that industry is paying between $3 and $6 a barrel just to dispose of this contaminated water. So instead of disposing of the water for $3 to $6 a barrel, we can actually treat it for 17 to 25 cents a barrel. Sorry, you can tell this is live because all my message notifications going on. So sorry, back to the point at hand. So we can do an incredibly effective job, better than most any other water system out there, and do so at a very, very small cost for the user. We sell the whole Nine Water system: machines, setup and validation, training, tech support, and maintenance, customized to address the composition of each client's water and their plant needs. Our machines are simple enough for a single part-time operator to manage all the functions of the machine, and we can also help customers find qualified personnel. One thing we don't, and we're not really interested in doing, is running a service. That's kind of heavy on the human resources department, and we'd much rather focus on being able to manufacture our machines and deploy them around the world without running a service to run the machines. Let's take a look at a couple of the industries that we work in. I've alluded to one in the oil and gas industry, but another one is the textile industry. Globally, there's about 62 billion pounds of textiles dyed each year to make apparel, and that uses up or contaminates about 5 trillion liters of water to do that. Not even including the amount of water it takes to grow fibers like cotton that are then turned into clothing. It takes about 2,900 gallons of water to produce a single pair of jeans. And then based on your kids and your own personal life, it might take that much to clean them on a regular basis too. Well, that water that the textile manufacturing industry uses contains a couple thousand chemicals, and in most developing countries, they're commonly this polluted water is commonly dumped into rivers and streams. Not only is this a huge waste of a precious resource, it's completely not necessary. And in places like China and India, over the last year, we've seen a huge rush to stop these kinds of contamination practices, and actually government money from both central governments in China and India, and to a lesser extent in the European Union, are being brought to bear to help companies purchase water treatment equipment. And we plan on getting in on that sort of rush to get green. Another segment that could use our help with its water use and reuse is the oil and gas industry. We talked a little bit about that earlier, but the oil and gas industry generates over 150 barrels of so-called produced water a year. This production or formation water accounts for about 98% of the entire waste stream for the entire oil and gas industry, from exploration all the way through to that gallon of gas at your local gas station. This produced water is 98% of that entire waste stream. Traditionally, this water has been taken, trucked off, and dumped into wells, and that's where that large figure of $3 to $6 a barrel comes from. But again, we can clean this water so it can be reused. It can be used to irrigate crops, for farm animals, and even put into human water consumption sources for 17 to 24 cents a barrel. And again, that beats the pants off of multiple dollars, $2 or $3 for other treatment systems, and as much as $6, $7 just to throw it away. Most people don't realize that fracking, and I know fracking's on everybody's mind, but fracking really doesn't use that much water at all compared to the amount of production water. And you can see in these photos, traditionally this produced water is left to sit around. Maybe it'll evaporate, concentrate some of the contaminants, but in that evaporation process, all those hydrocarbons are released into the air. And so that's something that most states have now prohibited. So the oil and gas industry has only got a couple choices. One is to treat the water, and again, the other is to do a deep well injection. And there's obviously some issues. You've probably heard about earthquakes being caused in Oklahoma and in Colorado and even parts of Texas because of this massive amount of water being put back in the ground. Industry's done a pretty good job at separating oil and gas from water. That's not really the problem. The problem is that they weren't able to get out all of those dissolved and even really fine particles, things again like metals, like arsenic, or the dissolved hydrocarbons like the so-called BTAX class of chemicals. That's benzene, toluene, ethylbenzene, and the xylenes. Those are the most dangerous organic hydrocarbons. There's many instances of when those have been banned around the world, and for good reason too. These BTEX compounds can cause cancer, birth defects, a whole host of other things. It's not just dangerous for humans, but for crops too, because those organic hydrocarbons can be taken up into, say, vegetables or into grains and then consumed by people without them even realizing it. So to help the oil and gas industry manage this volatile problem of way too much dangerous wastewater and what to do with it, which is also just discarded a valuable resource, one that we're running out of, we created this 9-water OG for oil and gas system. So I've said a lot, and sorry, John. Yeah, I heard you saying it's about time to get off the phone here. I would like to offer the opportunity for any of our listeners and our people viewing today. If you'd like to give us a call anytime, you can do so. You can find us on the internet at www.ixwater.com. You can certainly give John a call or call us directly on 303-277-9520.
Well, thanks a lot, Grizz. I mean, that was very informative, and I know that you had to step out there for a minute right at the end. So I'm going to answer some questions, that came in the best I can, and what I can't, we'll get back to you with Grizz, maybe live on a conference call. One of the calls that came in is basically, how has the company been financed up to date, and what are the current capital requirements? Right now, the company has had an internal round over the last couple of years of a small group of investors, and right now the company has opened up what we call the Series B round for $2.7 million. And this is a pretty interesting round because essentially we think at this particular point the company will not need any capital beyond this round because of the business model that the company has set up to do a just-in-time manufacturing process, which literally takes the customer's deposit and you can turn around a piece of equipment in a very timely manner and get it to the customer and collect on those particular equipment, without having to use additional manufacturing capital.
That's right. So I hop back in the room. Sorry, John. One thing in front of an investor, and that's a customer.
Oh, okay. So there you are.
Yeah, so I'm back. Okay, so great answer. That's exactly what we do. We use just-in-time manufacturing, and we take advantage of the fact that in this industry, in the water treatment industry, and in the oil and gas industry, it's normal to pay 50% up front and then do progress payments as someone's building out the plant. And between you and me, the 50% up front covers all our costs to deliver the plant. So we try to run about a 50% gross margin.
Yeah, and the reason that's attractive to us as an investment banker and dealing with our clients on this particular investment is that one of the things you're most concerned about is that the need for capital in the future is only dilutes the current equity owners. And so what we're looking at here is that this particular Series B is offering at a fairly good value, and because of the previous experience of this management team, we expect that within a 3-year period that we would have some type of liquidity event at a very good multiple, which essentially increases the rate of return for the current Series B investors. Another question that came up is, what do you have planned as future development?
Well, we're constantly refining how we do things to make sure that our products maintain their robust ability. They operate for 10 years with virtually no maintenance. But we're also looking at ways that we can automate some of these functions so that really the amount of time required for an operator is very little. Right now, it really only takes a few hours a day, so it doesn't even take one full-time person to run our plants. But we'd like to get it down to the point where we can, you can literally run the plant off your iPhone. We've got a good background in what's called supervisory control or control systems, and so that's just something we're kind of working on in the background. We also have some coming innovations in the area of dealing with water that's got a higher sort of radioactivity level than you would expect to see. Sometimes oil and gas guys will hit seams of radon, and then unexpectedly they'll have a radioactive problem. and we need to be able to respond. That's pretty simple technology, but making it work with our existing system so you can literally ship it out, plug it in, and they can keep going and get through that seam of radon, and then we'd probably, we might lease that equipment for folks that don't need it full time. That's some of the stuff we're working on.
Okay, one of the questions was, maybe I'll combine two. One was in what was the current commercial status of the company in terms of delivery, and another question was based upon that, maybe a discussion of some of the, wanted to know some examples of some prospects that you're talking to currently that are actively, that you're actually proposing equipment to.
Well, as we've said before, and as the PPM mentions, we've started a soft marketing campaign. That's a lot of direct calls, and even with that, I mean, it's a little bit embarrassing because we've got more work than we can handle now in terms of putting proposals together and configuring our machines for customers and giving price quotes. Last night, I sent in it's a fairly robust plant, about $5 million retail to us to a customer. They agreed on the cost per barrel, which is very modest. It's going to run about 15 cents per barrel, and again, usually, for treatment, it's $1 to $2, depending on what's in it for just basic treatment. So us doing it at less than 15% of cost is really attractive to them. They have a purchasing system. Our contact to contract time sometimes can be 6 months, sometimes it can be 90 days. But the good news is our turnaround delivery from the day someone orders to the day we set up is about 90 days. So that's one example. We also have a couple other oil companies here in Colorado that are going to install single units. Those will be sort of $450,000 to spend some time, try out our products, they fit with their workflow before they start buying multiple units to click them together. We've got around $30 million in the house of solid prospects. We use a standard sales technique where we go from, the sort of lead generation to a real sales prospect, and from there to, an actual sales process where we make sure they have the allocated funds, they've got a problem that we can actually solve. Coincidentally, we turned down an oil company yesterday and said, we cannot, and nobody really can handle some of the sludge that they've got coming up after their drilling operations. That's got to be handled in a more conventional manner, which, quite honestly, is landfill for that type of waste. But we're continually working on new customer prospects and getting those folks into our sales process.
So we estimate right now probably the sales prospect, I guess what you would call a pipeline, is about $30 million right now?
Yeah, right. That's what we're running, about a $30 million pipeline. And out of that, I mean, those are, again, qualified, prospects. Those are not leads. All that business could take 18 to 24 months to close, but we're also continually, increasing the size of the pipeline.
True. The old question came up always is competition or similar solutions that you're facing every day in out there in trying to market.
Okay, so let's break that down in two ways. One is sort of the way we've always done it, and the oil and gas industry has, they've made really good money over the last 115 years doing things the same way over and over. And so that's one piece of competition. That's that resistance to change, and I'll come back to that in a second. But the other side is, as I said, they're companies that are used to building massive infrastructure, concrete works, lots of steel, using very traditional things like settling ponds, like you might see at a municipal sewage disposal plant. That takes time. It could take up to 3 months to let a biological process treat that water. So, those really aren't even our customers. And then folks that are proposing to do real-time treatment like we do generally just only have one part of the solution. Say they can take out metals, or they've got a UV light system to reduce the bacteria count. Our system was designed to do everything except concentrate salt. And again, that's because salt content is going to vary widely. And most well operations that are using water for, say, new wells for hydraulic fracturing, they can take clean salt water and use it. In fact, there's a whole category of fracking called slick rock. And the slick part is the NaCl and even magnesium chloride that's in the water. So that's a useful thing, and it gives us an opportunity to take a big liability and turn that into an asset. Now, going back to the people that are resistant to change, there's two things happening. One is that the oil and gas industry, given the last downturn, prices are back up now, but they did everything they could to squeeze cost, except look at dealing with produced water. And that's now become a bigger and bigger issue. Countries like China or the European Union, they actually have to clean. There's no choice. But for the folks that have been sort of like dumping their water in a well, it's more attractive if they can save money, and again, our system does that. It's more attractive for those folks to treat that water and then reuse it. Again, that idea of taking a liability and turning it into an asset. And ultimately, it's because most places that you find oil and gas are also deserts. You know, you think about West Texas, Southeast New Mexico, Oklahoma, there's not a lot of extra water laid around. So if they want to keep up operations, if they want to maintain their revenue, they've got to have a supply of water. They're already bringing it up. All we got to do is treat it for them, and then, again, we take that liability and turn it into assets, something they can use in their production, and a lower cost overall.
Here's one about somebody asked a question about what countries outside the U.S. do you think will be the bigger markets or bigger than the U.S.?
Well, we're committed to the Southwest U.S. because we're here and it's drivable, right? That means our demos and our sales cost is very low. We're also committed to going big into China, and we're doing that in kind of an unusual fashion. Our equipment has no tariffs attached to it. We're not part of any sort of pending, trade discussions because it's about cleaning up environmental processes. Also, the Chinese government has now waived some of their more stringent requirements on predominantly Chinese-owned companies doing business. So in a recent trip to China, I saw a complete 180 on how they are treating U.S. companies. The deal with China is they never treated water, and they didn't even really have disposal wells like we do in the U.S. where you inject it in the ground. They were taking produced water and throwing it in a river. And the fine for doing it from the government was a few $100s. Now they've attached the death penalty to it. Now, obviously, I'm not a fan of socialism and communism, but if you want to get an entrenched industry to change how they do stuff, a severe penalty for breaking the law is one way to do it. So now we're literally, part of the mission-critical aspect. And there are a lot of companies rushing in. But again, they want to build these massive centralized plants that cost $20, $30 million. And on the proposal we put in last week, our cost per cubic meter to treat was around $1.75. The next competitor that we know that put in a proposal was at $14.63. So the competitor wants to charge $14.63 a metric ton or cubic meter, about the same amount of water, and we're down at $1.75. I mean, this is part of our philosophy. You can't be a little bit better. You can't be incrementally cheaper. You've got to be big leaps in order to enter these kind of markets. And then the third market is the EU, and that's really concentrated on the North Sea because there's an organization called OSPAR that recently, last year, put into effect new standards. And so the oil and gas offshore operators can put salt water back in the ocean. It's salt water, but there can't be anything in it. And again, that's where we come in. All those metals, the hydrocarbons, all that stuff that contaminate, water, they've got to get rid of. And, people are talking about barges, and we've got a nice transition time for us to get into the sales process. We're going to do it with established suppliers. We're not going to try to have some big sales army in China or a big sales army in Northern Europe or in the North Sea. And by doing that, it makes our personal ROI, our profitability a lot higher.
Yeah, this question probably dovetails to another one that came up, but based upon those particular opportunities, so do you see any barriers to scale up to meet demand?
I don't think we're going to have the traditional manufacturing barriers because a lot of our components are literally off the shelf. It's what we do with them and how we configure them. In terms of the media manufacturing, we've got capacity to go as high as 15 units a month. I mean, that's $7.5 million a month in retail sales. Upwards of $90 million a year. That's huge, right? Before we even have to, set up some larger manufacturing environment in the U.S. Now, in China, one of our current investors, who's a private businessman, he's actually Japanese, he owns a manufacturing facility with extra room in China, right in the oil patch. And we've got an agreement with them, just a handshake right now, but we're going to formalize the agreement to be able to use his excess warehouse space so that we can do manufacturing. Once all the equipment and everything is brought into the manufacturing space, it only takes about 2 work shifts, or about 16 hours, for 2 people to assemble one of our units. So our manufacturing is very modest. It's really, the biggest time delay is our supply chain, and we do have multiple sources. We've got our preferred guys, but if we have a hiccup from say somebody that's supplying us with the certain kind of piping or hose or valve, we've got other options to go with. So you're right. This is down to execution. It's something we're pretty good at, and we're not talking about thousands of units in order to get to a liquidity event. We're talking about hundreds of units in order to get to a liquidity event, and then let some very large multinational company use their supply chain, their manufacturing facilities, and their sales guys really take this global. We'll have made our money. Our investors will have made our money. We'll have done our job on behalf of the U.S. government, introducing this technology around the world.
Well, I think that's all the questions we have. Well, I'd just like to wrap up a little bit about the investment itself and the position the company and the investment is in. I think what you can conclude from our presentation of Griz's discussion is that the ramp to get this to be a $100 million company within 2 to 3 years is very viable, considering today, even just as they started to commercialize, $30 million just in the sales prospect line. The investment is only $2.7 million. So at this particular point, we feel that it's not a lot of capital, but it's enough capital to do what they need to do, and also enough capital to get them to be cash positive. So we feel that although this is not a lot of money, it's a kind of a limited window to invest. But we think that this particular round of investor is going to see a very good multiple within a short period of time, and we think 2 to 3 years is a pretty limited horizon, comparatively speaking. So again, we are right in the midst of this round, and we are going to contact everybody who's viewed the show today in terms of any more questions, information they may have on the company and on the investment, or you can call Frederick & Company. But we'll definitely be in touch with each and every one of you within the next day or two. So again, please feel free to give Greg Griz, Frederick & Company a call, and really appreciate your attendance today, and be in touch with all of you very shortly. Thank you. Thanks a lot, Griz.
John.
Thank you, Griz.
All right. We'll see you.
Yeah.